Hello friends. In the last session, we tried out the binary classification algorithm. This is the type of machine learning, supervised machine learning type, which comes under classification, and it's called binary classification, which was very clear. You know the outcome could be in the two classes, either class 0 or either class 1. Means whether you detect your email is spam email or not a spam email. The transaction done by the customer is a fraud transaction or not fraud transaction. The patient have a disease or not have a disease. So your prediction would be clear that in the two classes, and then we use the binary classification. But in the last session, we haven't used evolution of the our model. This is last session which we conducted, and here we only train the model using SDCA logistic regression, and then evolution. We made the evolution, but we didn't dig it down too much in the evolution matrix. So today agenda is to understand what are the evolution matrix and how it is beneficial. So the evolution matrix in the binary classification is first is confusion matrix. So let's try to understand what is the confusion matrix and why especially we call this as a confusion matrix. So confusion matrix, this is a structured table used to evaluate the model performance of how many positive were there but detected by negative, how many negative were there but predicted by positive. So this is called, is there any confusion in the model predictions versus access value? That's why it's called a confusion matrix. So try to understand with this example. Here you see this confusion matrix is a straightforward or table which divided into two rows and two columns. So here you see our actual value. This will denote the actual value, and this will denote the predicted value. So what does mean by this? Let's try to understand one by one. So actual value was positive. So let's say the actual value was detected as a positive. So here positive value given to the model, and then model also detect the positive. This means correct detection by the model. So model predict positive and my actual value was also positive. So there is no confusion. So that was pretty clear. Next one is negative. Let's understand this. My actual value was negative and model correctly predicted as negative. This is also fine. This is called true negative, means right prediction done by the model based on the actual value. But now the main question comes to this area where you see false. Can you see false? What is this? False positive. Let's do with this false positive. What does it mean by false positive? Your actual value was negative. Yeah, actual value was negative, but model predicted as positive. This means false. Model did the wrong prediction. This is called false predict. Means wrong prediction done by model. My email was normal. If you took an example email where we model should detect is this spam or not spam, and what right email would be detected as a spam email by the model. This is called false positive. So this is the problem detected by the model. And then another area we have false negative. False negative is also the false performance of the model because actual value was positive but detected by the model as a negative. Means if you are building a machine learning model for transaction tracking, and normal customer was doing the transaction and you detect, your model detected the fraud transaction done by the customer. So this is called false negative. That's why it is called confusion matrix. That's pretty clear, which describes the ratio between actual versus predicted values. That's why it's called confusion matrix. Now confusion matrix, why it is important? Because in the confusion matrix, accuracy alone hides the mistake. If you calculate the accuracy that would be not correctly, then that would be not 100% correct. In this way, it's derived some more matrices. What are more things are derived, more matrices are derived? One matrix is accuracy. As I explained, if you completely depend on the accuracy, that might be possible. It is not 100% accurate. So we also need to check, we also need to cross check the actuality of the model, because accuracy is the overall correctness of the model, where positive negative combine and then define the rate. There could be a reason. Let's say if a one class is a dominant factor of the model, then your accuracy will be wrong. What is the dominant factor? If you are new, you can refer to my PFI video where I describe what is permutation feature importance. Where this is PFI, please refer to that here. And then we here, if we are not able to 100% trust on the accuracy, then we will check the precision. What is the precision? Precision is also checking a false alarm control. Means, is there anything false detected by the model while your actual values was right and detected wrong by the model? So that's called the precision. Here you can see in this area. True positive and true positive, true false positive, and true. This area was detected. This is the precision area. Next is recall. Why we use the recall? Missed detection by control. Is there any data missed? If you have confusion, try to understand this. Precision. Precision means your value was positive. Of what wrong detected by the model? Is there any missed things done by the model? Any false alarm? This here you need to control the false value. Maybe I'll explain one more time. The precision to you means the positive next or the actual value detected by the model, but here we like to figure it out how many positive was detected by model. Out of the positive detection, how were actually positive? It might be possible your actual value was negative but detected by model as a positive. So this is where we check the precision. And then the next matrix, we use the recall value. The recall value is out of actual positive. Actual positive were there in the data, and how many missed by the model. Means how many values model missed to detect as the actual positive. Let's look at this area. Value was positive, but is there any false negative detected by the model? And here we call the recall. And combination of these both as a ratio we know as F1 score. These are some matrices, guys, for classification. So today in this session I'm especially discussing about the binary classification, and these are the matrices which we need to use for the binary classification, where we evaluate our model performance. Now let's go back to the code where we will actually see the performance of the model, which we already prepared in the last session. So till here this evaluation was done. Now we need to print the matrix. Let's say print the matrices. What is the accuracy? Let's print it. Okay, print the accuracy. Let's see, it's 99.71%, the overall accuracy of a model. Let's do more, dig it down more and try to understand more parameters of the model. Let's print F1 score. What is the F1 score? Let's print that. Let's say F1 score. Okay, let's see what is the F1 score. So the F1 score 99.76. This variation easily can be seen to you, because here we see this F1 score comes with the precision and recall. So that's the final outcome that we receive from the model as an evaluation. And then this important factor is confusion matrix. We talk lot more about the confusion matrix. I think we need to understand the confusion matrix as well. Let me try to use the code for confusion matrix. How you use the confusion matrix, that's pretty clear. Let's say confusion matrix, okay, and then confusion matrix. We can define a variable confusion matrix and matrices dot confusion matrix. Here we can print our confusion matrix. Let's do that. Okay, let me change the code. That's not any problem. Okay, let's print out the confusion matrix. So this is the confusion matrix. Here we can see true positive 8018, false positive means actual value was positive but detected false by the model, detected negative by the model, it's called false positive. False negative, actual value was negative but false negative by model. True negative, how many value was actually detected by model. So these two, true positive, true negative, is the right prediction by the model. False positive, false negative was the wrong prediction by the model. So here we can see the wrong prediction by the model is very less. The ratio is very less. That's why the overall accuracy of the model is correct. Why it's happened? This is due to we have the data. This ultimately depend on the data set, what kind of data you do have. This is based on the data we do have, that was actually pretty cleared, pretty clean data we do have. If you have imbalanced data, then definitely your accuracy and the mod evaluation matrix is confusion matrix, and the true positive, true negative, false positive, these matrices would be changed. If your matrices would be changed and you didn't find the best accuracy, in that case you need to perform the training on your model. So we need to fine tune our model. So this is all for this session, guys. In next session we will try to understand the further regression, further the trainers for the binary classification, which is supported by Microsoft ML.NET, which I already given you the link on this. Here you can see, if you click on it, then you can see, yeah, this is binary classification, and binary classification trainer supported by Microsoft ML.NET. We do have many. I will try to cover one by one as much as possible for your better understanding, and then we move for multi-classification and then multi-level classification. So thank you very much for watching my video. If you have any question, feel free to comment it. I will be happy to answer your question. Thank you, guys.